Right, so we're going to look at kind of step by step. If you're given two aqueous ionic compounds and you are to predict the products and write and balance the reaction equation for a double replacement or double displacement reaction. It's kind of a good process to follow when doing these problems. The first thing, like let's say that I gave you the names of your reactants. So if I wanted to combine aluminum nitrate and hydrogen sulfate and see what happened, a good place to start is realizing that these are both two solutions, two ionic solutions, and maybe start by writing their formulas as reactants in a skeleton equation. So aluminum nitrate, I've got aluminum, which forms a 3+ in solution, and nitrate, remember, is going to be your NO3 within one negative charge from the back of your periodic table. So we've got NO3 with a 1-. Again, swap and drop, and you should get Al NO3 3, and that's aqueous. And we want to do hydrogen sulfate as well. And remember, sulfate's a polyatomic ion, so we're going to treat hydrogen as an ion as well. So hydrogen is in group 1, so it should form a 1+ as an ion. And sulfate, remember on the back of your periodic table, is SO4 with a 2 negative charge. So if you swap and drop, we should get H2SO4, and it's aqueous. I'm going to just do this so you know that that's what our skeleton equation would begin with. Okay, so far so good. The next step is to make sure that you can identify the cations and anions in each compound. So with double replacement reactions, it's kind of like two different couples going to a school dance and they decide to swap partners for whatever dance. Okay, so everybody swaps partners and it's with two new pairs. All right, so you got to figure out what the different components of each, group of two, each partner, or each, in this case, compound, what those two components are, so that way you know when you swap what it's going to be like. Okay, so the first thing is to identify your cations. So we should have two cations and two anions. Remember, cats have paws, so the cations are going to be the positive ones, but also cations are always listed before anions in the formula. So you see Al, that has to be a cation. And remember, as an ion, you have to show its charge. Okay, two options. You could either go back and say, well, I know Al forms a 3+, or if I didn't give you the names, if I already gave you this part of the formula, you should be able to reverse swap and drop to see that that Al should be Al3. You know nitrate is a 1-. So we've got Al3+. The cation from this other compound is going to be hydrogen with a 1- charge. Or excuse me, positive. Ooh, the 1 positive. Okay, we've only got one of these sulfates, and that 2 came from sulfate, so the 1 that's understood came from hydrogen. But again, if it's hydrogen as an ion, it has to be a 1+ if you're treating it like a cation. So these are our two cations. And here's the other set. We've got anions. So the anion from our aluminum nitrate would not be aluminum, so it must be nitrate, NO3 1-. And then we've got sulfate over here, SO4 2-. Okay, what you want to do is pair up each cation with the anion from the other compound. So aluminum originally is with nitrate. So instead of it being with nitrate as an anion, I'm going to put aluminum with sulfate. This is aluminum taking hydrogen's boyfriend and giving hydrogen her old boyfriend or whatever. Okay, so now we're going to have Al3+ with sulfate. Okay, so just pair them up for right now. And then you're going to take the other cation and pair it up with the other anion. So if you look here, Al ended up taking sulfate and hydrogen ended up taking nitrate. Okay, you're going to write the formulas for the products using these pairs. Okay, and really it's best if you just add them on to the end of this equation. So if you already have Al NO3 aqueous, reacting with H2SO4 aqueous to produce some products. You're going to just swap and drop to write your formulas for your products. So Al3 plus and SO4 2 minus, I'm going to get Al2 SO4 3. And since those are both 1 and 1, we should get HNO3. Okay. Now we have to use our solubility rules to predict the products, or the states of our products. Okay. So solubility rules, I want to look for anything that deals with like aluminum, if that's something, or with sulfates. So you're going to want to look for anything that talks about your cations or anything that talks about your anions as a general rule. And we want to look for anything with like H's as a cation or with nitrates, okay, as a general rule. So H or NO3. And so we should be able to figure something out about these. So I'm going to use the back of my periodic table, the same one where you have your polyatomic ions. You also have these activity series. You'll see some solubility rules here. Okay, so the first one says all common salts, remember those ionic compound, of group 1 metals and ammonium ions are soluble. Okay, so for something to be soluble means it will dissolve in water. So if it dissolves in water, then that means its state would be aqueous. If it's insoluble, it means it won't dissolve in water, so doesn't dissolve. So if it doesn't dissolve in water, you're going to end up getting a precipitate. Now, unless it's water, it's going to be a solid precipitate, or if it's like a hydrogen gas or anything like that, it should be gas. But for, I think, all the problems that I think we're going to assign, we're going to use solid as a precipitate. Okay, that's a technical term. It was one of your definitions for Unit 4 vocab as well. Okay, well, I don't have any group 1 metals. I've got hydrogen in group 1, but I don't have any group 1 metals. And I'm not dealing with ammonium, so that rule tells me nothing. Okay, all common acetates and nitrates are soluble. Well, I do have a nitrate here, so that's saying that this should be soluble, which means it should dissolve in water and be aqueous. Okay, let's just see if we can find anything else. All right, all binary compounds, that's 2 elements, of group 17 metals or elements other than fluorine with metals are soluble except for those of silver, mercury, and lead. Well, I don't have anything dealing with one of our group 17 elements. All sulfates are soluble, got a sulfate, except those of barium, strontium, lead, calcium, silver, and mercury. Well, I'm not dealing with any of those, so this should also be soluble. So we should get a Q. All right. So if both of those are soluble, that means we can go back and put those symbols here. Okay. For us to write the complete equation and balance it, we're going to have AlNO3 aqueous plus H2SO4 aqueous. Okay. That's going to yield Al2SO4 aqueous plus HNO3 aqueous. And remember, I know those states because of my solubility rules. Okay, we need to balance the equations now, or the equation. So I'm going to use this piece of paper as some kind of extra scratch paper. Okay, and I'm going to do this the method we talked about in class today, just to kind of give some extra practice. So since each of these substances are different, I'm going to name them substances A, B, C, and D. This is not going to be fun. Okay. My elements I have are aluminum, nitrogen, oxygen, hydrogen, and sulfur. Okay. I know that aluminum, there's 1 aluminum in every A, so I'm going to just say that it's equal to A, because however many A's I have, I'll have the same number of aluminums. Law of conservation of mass says whatever I begin with, I must end with. So if for every number of these aluminum sulfates, or Cs, I should have 2 atoms of aluminum, so I should have twice the value of C. Okay. For nitrogen, I have 3 times however many A, and that's going to equal, due to law of conservation of mass, whatever the value of D is. For oxygen, I should have 3 times 3, so 9 times the value of A, plus 4 times the value of B. And that whole side must equal this whole side, so 3 times 4 oxygen, so 12 times the value of C, plus 3 times the value of D. Okay. For hydrogen, we've got 2 times the value of B, equals, that's it, equals, over here, 1 times the value of D. And for sulfur, we've got 1 times the value of B, which needs to equal 3 times the value of C. Okay, if we do A, B, C, and D, and let's set A equal to 1, all right, we'll see if A is 1, so 1 is equal to 2 times C. If you divide both sides by 2, you get C is equal to 1/2. Okay. All right. So I'm probably going to come down here. Well, we could do this too. Okay. So over here, since I also know that A is 1, then that means 3 times 1 is D. So D should be equal to 3. Okay. And to find B, I've got a couple options. I might just do this. So B, because it's already solved for B, it's going to be 3 times 1/2. So it should be 3/2. Okay. So this is the right proportion, or the right ratios of A to B to C to D, or of aluminum nitrate to hydrogen sulfate to aluminum sulfate to hydrogen nitrate. Okay. Remember, you can't have half numbers, so you're going to multiply everything by 2 to correct it. So you get 2 of compound A reacting with, remember those 2's will cancel, so you'll get 3 times compound B. Those 2's cancels. For every, if you combine these 2, you'll end up getting 1 of compound C and 6 of compound D. Okay. So we're going to balance our equation by putting 2, 3, an understood 1, and 6. And that'll balance it.